Morning all. The last lesson now on the inheritance topic. So we're going to look at classification. Before we do that, we need to do some catch up and some stickability on the topics that we've previously been taught. So the best thing to do is to get a whiteboard and pen out in front of you. If you do not have a whiteboard and pen, just get a pen and a piece of paper or your exercise book out and work through these do it now questions. So question number 1. Name the 6 words in an evolution answer in order, please. This should take about 1 minute. Question number 2. Describe 3 ways that fossils are produced. Remember, this is not teeth, bones, shells. It's the 3 different processes that will allow fossils to be produced. Again, I have 30 seconds to answer this question. Now this is something we've not looked at yet. It's the process of extinction. Hopefully you've all heard of the word extinction. So the first thing I'd like you to do is define extinction. I'd then like you to think of at least 3 ways that organisms become extinct. Just as a bit of clarity, you cannot say the answer because they are not adapted to their environment. They may well not be adapted to their environment, but what makes them become extinct? So what is it that specifically means they will no longer be able to survive in their environment? Again, just 30 seconds to define it and then give at least 3 examples. Very short, sharp question here. Just describe the process of genetic engineering. A very basic question. You don't need to go into all the detail about prokaryotic cells. That question will come up next. So again, just 20 to 30 seconds. How does the process of genetic engineering happen? What are the 2 main things that would need to happen? Now this question is slightly more detailed. This is a specific example of genetic engineering. We looked at this on pages 30 to 31, the process of genetic engineering with prokaryotes. So how is insulin produced using genetic engineering? Think about the different stages that need to occur. Where do you get the gene from? What do you do with that gene? And then how do you end up producing human insulin to be used? Again, this should take you probably about 2 minutes. So I have 2 minutes on the clock and start the 2 minutes now. Now you've had a chance to recap on all your understanding of genetic engineering and selective breeding. I'd like to go to Google Classroom, so log in on Google Classroom. I have now set you a task. It's a 6-mark question on evaluating genetic engineering, but specifically looking at the use of genetic engineering in farming. I'd like to type this into your Google Classroom answer and submit it by next Tuesday. I will then go onto Google Classroom and I will mark it. So please ensure you've corrected that. And then once I have marked it next Tuesday, you'll need to go back in and have a look at my edits. The new topic for today is the classification of living organisms. In particular, we're going to look at how Carl Linnaeus used information to understand the Linnaeus system. We'll then look at the impact of scientific developments on the classification methods, and we'll finally look at evolutionary trees to interpret ancestry. Ancestry effectively is where do organisms come from? Where have they evolved from? Do they share a common ancestor? And when and where was that common ancestor around? So classification is termed as the grouping of organisms. Previously, the grouping of organisms or classification, when Carl Linnaeus did it, was based purely on what organisms looked like. As scientists have developed their understanding of genetics, so if you think about thinking back in time, Mendel and Darwin, the 19th century, particularly 1953 with the discovery of the Watson and Crick double helix, we now move on to entirely using genetics to to group and classify organisms. What I'd like you to do is just move through the next few slides. You'll then have an opportunity to make your own notes in your booklet. So when I was 11, which was in 1995, I was taught a very simple method of remembering the taxonomic groups. So I learnt king penguins climb over frozen glacial slopes, and that still has lived with me to this day 24 years later. So what I'd like you to do now is to develop your own method of remembering the taxonomic groups in order. It could be that you use the same one as me. It could be that you make up your own kind of little poem to remember those taxonomic groups in order. So it's kingdom, phylum, class, order, family, genus, species. How can you best remember what taxonomic groups comes first? At the back of your inheritance booklet, or potentially you might just want to do it on a sheet of paper or in your exercise book, I'm now going to put a list of questions that will get progressively harder linked to classification in particular. I'd like you to complete these questions to check for your understanding. Once you've finished it, if you could email me the answers to your questions or take a picture and send me the picture of the questions that you have taken. By next Tuesday, I will have a slide that has the same questions on them, and I will then provide my answer to those questions for you to green pen at the beginning of our next lesson. So that is the inheritance section entirely finished now. At the last couple of pages, to pages 38 to 39, you have the specification rewritten. I'd now like you to rag the specification. What topics do you understand and what topics do you not understand? You'll then have an opportunity to write your 3 weakest topics. I'd then like you to spend some time creating revision resources on those 3 weakest topics so you can improve upon those. Any questions, please email me.